I'm very happy to join this meeting. Particularly, I'm seeing some old friends here. Good evening, everybody. Nice to meet you again, and thanks for this invite in this august body of geoscientists. And I have great pleasure in sharing some of my research work on the Eastern Ghats Belt, where most of you people are sitting there on the Eastern Ghats Belt. My association with Eastern Ghats started way back in 1980. After almost at the time I joined Jadavpur University, leaving Geological Survey of India. At that point of time, I went to the Eastern Ghats to collect some samples of graphite required by one of my foreign collaborators for some experiments. So I encountered certain peculiar looking rocks there, particularly some blue colored rocks, which I could not identify very easily, that actually increased my curiosity to look at those rocks in more details. And there started my Eastern Ghats venture, which continues for nearly 40 years now. So I'm going to share some of the results that has been obtained from the Eastern Ghats, but this is not only our work, but the work of all the people who have actually contributed in the geological evolution of the Eastern Ghats. So the title of the talk is the Eastern Ghats Belt and the three supercontinents. I will be talking about the three supercontinents, Colombia, Rodinia, and Gondwana. And this total time span is more than 1 billion years. And the Eastern Ghats bear the imprints of this 1 billion year history. So naturally, it is quite interesting for a student of geology to know it in details. Now, this is how I have organized the talk. So I will just briefly introduce what is ultra-high temperature metamorphism. This is something that was not there when we studied metamorphism in our college or university days. It came into existence after 1980, and the Eastern Ghats played a very major role in documentation of ultra-high temperature metamorphism. Then I will briefly touch upon the geology of the Eastern Ghats Belt, which all of you know very well. Then comes the main part of the talk when we will talk about the pressure, temperature, time evolutionary history of the Eastern Ghats Belt, the metamorphic history of the Eastern Ghats Belt, and we'll try to do some tectonic modeling. And like any other model, the model is a model, so this is subject to revision all the time. So we have proposed something, but it can be changed or revised depending on incoming new data. And then I will comment on the role of the Eastern Ghats Belt in the supercontinent correlation, particularly those three supercontinents. So let me begin with a very textbook type definition of UHT, or ultra-high temperature metamorphism, which is from 900 degrees Celsius to as high as 1050 degrees Celsius. Some people have also taken it to 1100 degrees Celsius, but doesn't matter. What is important that the temperature of metamorphism should be more than 900 degrees Celsius, and the pressure, of course, it varies from 5 to 12 kilobar, so at mid-crustal to deep crustal depths. So there is no pressure connotation of UHT metamorphism. It can vary quite a lot. This is the compilation of Mike Brown, where he showed the occurrence of UHT metamorphism in these orange circles, where you can see there are a lot of areas which experienced UHT metamorphism, and the temperature range is nearly 900 and higher. But as you can see, the pressure range, the depth range is from nearly 25 kilometers to 50 kilometers, that is mid to deep crustal levels. But let me show you the compilation of Kelsey and Han in 2014, which shows on the map of the world the occurrence of the UHT metamorphic terrains. And as you can see, more than 50 have been discovered in 2014 and now a little bit more in number. And the Eastern Ghats Belt here, number 22, this is the one which is the topic of today's discussion, and it comes very prominently as a documentation of ultra-high temperature metamorphism. As you can see, we have ultra-high temperature metamorphism from all over the world now. And it should be actually more common than what is believed. So what are the required conditions of ultra-high temperature metamorphism at great depth of 40 kilometers? So I quote from the work of Chris Clark of 2011, where he tabulated 4 criteria. That is the elevated upper crustal heat production that is obviously necessary to raise the temperature to 900 plus degrees Celsius, and the slow erosion. Slow erosion means the material should be at depth, at high temperature for a long time, so that metamorphic equilibration can be achieved. And this is connected to the number 4 point, that is the suitable tectonic setting that allows long stay of the rocks under high temperature conditions. And the 4th point is suppression of partial melting. Now, why this is so? Simply because that if partial melting progresses, then more and more melt will be produced and the temperature of the rock will not increase. So you need to suppress the partial melting so that the temperature of the rocks increase. In some ultra-high temperature terrains, of course, there is little evidence of advective heat transport by magmas. In some terrains there are, but not in the Eastern Ghats very much visible. Prograde pressure temperature paths can be both clockwise and counterclockwise, and the retrograde path can be both isobaric cooling and isothermal decompression. So anything can happen regarding the pressure temperature time path. And several tectonic settings have been proposed for UHT metamorphism. I quote from again Kelsey and Han 2014 review paper, where they listed 4 different possibilities: extensional collapse or overthickened crust, or mantle delamination that brought the asthenosphere close to the moho. Actually, this is basically very important, that the asthenosphere should come closer to the moho so that the temperature increases. Then the second model is extensional accretionary orogenesis. The third is the closure and thickening of back arcs. Now, all of us know that back arcs are the areas of enhanced heat flow. So this is a possible tectonic setting for UHT metamorphism. And the last one is a slab break-off model and syn-extensional magmatism in hot back arcs produced by decompressional melting of the asthenosphere. Now, in the Eastern Ghats, many of us have proposed slab break-off as the possible reason for UHT metamorphism, but this is again a model, and there are other models as well as available. So we introduced the Eastern Ghats Belt here with a very sketchy geological map, where you can see it is along the eastern coast of India, starting from near Cuttack and going down to near Ongole in Andhra Pradesh for over 1,000 kilometers along the east coast of India, and it is bordered by 3 cratons actually: the Singhbhum craton on the north, the Bastar or the Bhandara craton on the west, and in the south, the Eastern Dharwar craton comes into contact with the Eastern Ghats Belt. So this is a typical mobile belt which is fringing three different tectonic blocks of India. So what are the problems that we deal with the Eastern Ghats? That the Eastern Ghats, why it is so important? It is important because it is the key to any model of Indo-Antarctic correlation. Well, there are models and models of Indo-Antarctic correlation proposed by different workers. We also played our role, but others also produced models. But in each model, Eastern Ghats is there. So it is a key area in Indo-Antarctic correlation. The question is, do we know precisely the tectonothermal evolution of the EGB? Second, we now know that the EGB itself is a composite terrain with at least 4 isotopic provinces, each with distinct tectonothermal histories. So a natural question is, which part was connected with East Antarctica and at what time? We'll see that the area is quite complex. So there are several areas which were connected to East Antarctica in different times. And how and when did these subterranes got amalgamated with the rest of India, so that we have the current geological map of India produced? Precambrian belts commonly evolve through multiple orogenic cycles. Now, a fundamental issue is to deduce the duration of each cycle, because we know that there is a history of 1,000 billion years. But how many cycles of orogeny within this 1,000 billion years? And that raises a simple question, that are the EGB granulites monocyclic or polycyclic? We strongly believe that it is polycyclic, it's not monocyclic, it's not one orogeny and not one burial and not one exhumation, but repeated burial and repeated exhumation. The crucial results that we obtained over the years is that the Eastern Ghats belts experienced one phase of UHT metamorphism at lower crustal levels that caused extensive partial melting, but the UHT metamorphism occurred at different times in the different isotopic domains. So we do not get UHT metamorphism at one particular time in the Eastern Ghats. The UHT metamorphism was on counterclockwise PT path. Now, there was some disagreement on this particular issue at the earlier stages, but now I find that all the workers have converged into this particular model of counterclockwise PT path during the UHT metamorphism. The UHT granulites of the Eastern Ghats belts were brought near the surface by later multiple orogenic cycles, which have pre-T trajectories quite distinct from that produced the UHT metamorphism. So that is one very big result which has come out through the work of not only us, but by a lot of people working on the Eastern Ghats belt. But we now agree that the Eastern Ghats belt bears evidence of multiple orogenies. So this is the general geological map of the Eastern Ghats belt taken from Ramakrishnan et al. Of course, Jayantananda was one of the co-authors, and this map was produced for over, it's a compilation map, so naturally many years of work lies behind production of such a geological map, which is the most authentic geological map that we have from the Geological Survey of India. And of course, I hope Jayanta is here today. Now, this is his map. So we have different lithotectonic domains in the Eastern Ghats, which are called the Western and the Eastern Condylite Zone, the Central Migmatite or the Charnokite Migmatite Zone, and the Western Charnokite Zone. And there is a transition zone which is bordering the Eastern Ghats with the Bastar or the Bandara Craton, and also with the Singhbum Craton. So this is the general geological map of the Eastern Ghats from the Geological Survey of India. Later work, however, showed particularly the neodymium isotopic measurements by Rickers et al. They showed that the Eastern Ghats is actually a collage of different isotopic domains and provinces, which they named as domain 1A, domain 1A, domain 1B, domain 2, domain 3, and domain 4. That is the work of Rickers et al. 2001. And each domain has a characteristic neodymium model age, which is different. So it is they conclude that the Eastern Ghats is a collage of different subterranes. Within 2 years, there was a partial modification by the same group, not by Rickers, but by Michael Wright and Christoph Dobmeier, when they revised the geology of the Eastern Ghats, and they divided the Eastern Ghats into several tectono-metamorphic provinces and domains, which are not exactly coinciding with the isotopic domains. As you can see that here, this is the Eastern Ghat province, by far the largest province in the Eastern Ghats, the Eastern Ghats province, which actually comprises the isotopic domains of 2 and 3 of Rickers et al. So it is a revision, but we will show in this particular talk that the geological history of this region near the Chilika Lake and near Vizag are different. So I still believe that the isotopic domain map of Rickers et al. Represents the actual scenario much more clearly. Whatever, without going into that controversy, this is known as the Eastern Ghat province, which is in contact with the Singhbum Craton here, with the Rengali province, and this is the Rengali province, and we have the Singhbum Craton bordered by a major shear zone, and all along they call the shear zone as the terrain boundary shear zone. I understand there was a talk by Tapas Biswal in this particular forum where I'm sure that he talked about the TBS said, because he worked particularly in details in the contact of the Eastern Ghat province with the Bastar Craton. And the TBS said, according to the map of Dobmeier and Wright, continues down below into what they call the Krishna province. So it's a mind-boggling thing, I understand, that the geological map shows different lithotectonic domains. The isotopic map shows different isotopic domains, and the Dobmeier-Wright classification shows different lithotectonic domains. So the question is, which one is correct? The point is that our work and the work of many other people showed that there are considerable differences between the domain 2 and domain 3 in the geological evolution. And domain 4 is also having a completely different geological evolutionary history. And we'll show that even the domain 1A has got a different geological evolutionary history. So 1, 2, 3, 4 all show different geological evolutionary history. So in that respect, this map looks to be more authentic or represent more actual scenario. Anyway, this is what we got for over 40 years of studies of the pressure temperature evolutionary history of the different isotopic domains. So as you can see, each domain colored in different pattern. This is This is domain 2, blue. Then you have the red one is the domain 1. The domain 3 is the black one, and the green one is the domain 4, or the Bengali province. So you can see yourself that each domain evolved differently. It's not only the pressure temperature path, but please look at the numbers of ages. You see the ages are also quite different. So it's a very complicated scenario in the Eastern Ghats Belt. Not the entire belt did not evolve as a single entity, but it evolved in different parts. So naturally, this has a connotation on Indo-Antarctic correlation. So which part was in contact with East Antarctica at which time? This we have to determine through this work, comparing with the geological evolution of East Antarctica that we already have data on those parts. So this is something that we are going to do here. And I will now go into all the 3 different domains. I will exclude the Bengali province from discussion, but I will go into the other domains here, the tectonic evolution, and I will refer to this PT path separately now. So we start with the domain 1, that is here, the southern part of the Eastern Ghats Belt. And this is the history that what we got. It has got an ultra high temperature metamorphism at around 1.76 billion years ago, followed by an intrusion of Charnokite at 1.72 billion years ago. This is from the Kondapoli area, Kovac et al. Date. And then we have another UHT metamorphism at 1.6 billion years ago, followed by a third phase of granulite fascist metamorphism, not in UHT, at 1.54 gigaeon. So M2 is actually comparable with metamorphic structural reworking of the Napier complex in East Antarctica, particularly near the Napier-Raynar boundary. We have extensive reworking at 1.6 billion years ago. So does it imply a spatial continuity between India and East Antarctica, particularly the domain 1 of the Eastern Ghats Belt and the East Antarctica? So the history is, if you please remember the history, and I go to the domain 2, you will see a completely different geological history in the domain 2. Domain 2 does not have any history of 1.7, 1.6, 1.5 billion years. We have the history, metamorphic history, beginning at around 1 billion year with an UHT metamorphism. Now, this particular UHT metamorphism at around 1 billion year was again not recorded in East Antarctica. So there is no spatial continuity between the domain 2 and East Antarctica at 1 billion years. But then it follows, there is a series of orogenic movements between 0.95 to 0.91 billion years. And these are definitely equivalent to the Raynar event in East Antarctica. So around 0.95 billion years ago, that is 950 million years ago, there is every possibility that the domain 2 of the Eastern Ghats was spatially continuous with the Raynar terrain in East Antarctica. And this is the pressure temperature path. Please follow the blue line where you have this UHT here at 1020 to 990, followed by these tectonothermal reworkings, and a final is a small reworking during the Pan-African event at around 500 million years. But this is not regionally developed in the so far in the domain 2. It is locally developed, but it is pervasively noted at every place close to the shear zones. And this was the original work of Metzger and Koska in 1999, and now followed by a detailed work of Axelson et al. In 2020 in Precambrian research, and we have done some more dating to confirm those findings that we do have Pan-African reworking, but it is not that extensive as the reworking during the Reinhardt event. Now, the third domain is the Chilka Lake domain here, this domain, and this domain has got a history which is absolutely different. We have an UHT metamorphism which is close to what we observed in the domain 2, around 0.98 billion years. But then we have two different orogenic events here, one at 0.75 billion years, that is 750 million years. Please follow the black line here. And then we have a very high-grade metamorphism at 0.52, that is during the Pan-African time. So this particular domain behaved quite differently from this domain at 0.5. So this has given rise to a speculation whether the Eastern Ghats at before 0.5 billion years, did it have the Chilka Lake domain along with that, or Chilka Lake domain came and joined with India later? Now, there are views and views, but one of the views say that this is actually the Chilka Lake domain, or the domain 3 became a part of India only during the Pan-African metamorphism, not before that. So this was an exotic block. Where was it lying? These authors say that this was lying near the Prince Charles Mountain in East Antarctica. I will show you the model in more details, but basically, one thing is very clear, that the metamorphic style, metamorphic PT path is quite different between domain 2 and domain 3. And as I showed earlier, that domain 1 has a completely different metamorphic evolutionary history. So these are sub-terrains in the Eastern Ghats Belt. And this is the Nagavalli Bahamasdara shear zone. Now, Chetty Garu is here. He knows it much better than me. Now, this is the Nagavalli Bahamasdara shear zone. And this actually was taken to be the boundary between the domain 2 and the domain 3. So anybody doing a geological map here cannot deny the existence of a major shear zone. Whether that's the boundary or not is, of course, an interpretation. But the question is, this is a major shear zone, like the shear zones here. And the eastern boundary of the Eastern Ghats is, of course, the shear zone, which is known as the TBSZ, or the terrain boundary shear zone. So one thing is very certain, that the metamorphic history between this and this are different. And if you look at, please look at the green one, which is, I'm not going to elaborate because I have no personal experience of working in the Rengali province. So Shoibali is sitting here, so he has done work on this domain. He can accept or reject what I am saying here, but this is I have taken from other people's work. Then you can see from the nature of the PT path that it is completely different. So even if we disagree in the numbers or the nature of the PT path, we can see that it is different. So the Rengali province is different. The Chilka Lake province is different. The Vizag area is different. and the Krishna province or the Ongol domain is different. So we have 4 different terrains which amalgamated together to form what is known as the Eastern Ghats Belt today. So that's the interesting finding. Now we go into some models. As I said, that these are models. So what we visualize that in the domain 1, that is the southernmost domain, the metamorphism, the tectonic evolution was caused by the collision between the Dharwar Craton and the Napier Craton of Eastern Ghats. In between came the Konapole magmatic arc, which we all know that we have the work of Mr. Lilanandam, for example. For example, in the Konapole magmatic arc, and we have around 1.76 billion years ago, this arc formed with its mafic, ultramafic complex along with chromitite deposits. Then Charnockite magmatism at around 1.72 gigaeon, followed by a regional UHT metamorphism at 1.6A, which the authors think that is the work of Sarkar and Singh. They think that this is caused by subduction rollback. And then finally at 1.54 GA, the entire thing, the Dharwar Craton and the Oy Garden area, the Napier complex, they became together. So this is the Indo-Antarctic correlation part of Columbia, because at this time, the Rodinia did not come into existence. So if this is true, then this is the story of Columbia that we are talking about. So the other part of the Eastern Ghats Belt has got no bearing so far with Columbia. We have no old dates in the other part of the Eastern Ghats. So it's only in the southernmost part, which was a part of Columbia and part of the Dharwar Craton Napier complex amalgamated area. And we have this Kandra ophiolite and the Kandra ophiolite coming around at this 1.5 GA time. So this is what people have visualized. So although the source is our paper in 2017, but the data has been, this story has been built up on the basis of the data generated by lots of groups of workers, not only us. So the details can be obtained from our review papers from where we took this data. And coming to the second domain, the domain to the area around Vizag, for example, now that's completely different. So here we start with the opening of an ocean basin, which is mainly the work of Devashish Upadhyay from IIT Kharagpur, who first pointed out this particular around 1.45 billion years ago. From detrital zircon studies, he concluded that an ocean basin opened up, extensional ocean basin between the Indian bloc and the East Antarctic bloc. Now, the Indian bloc contains Basta, Dharwar, EGB, domain 1, and was separated from the East Antarctic bloc by an opening of an ocean basin at around 1.4 billion years, which caused sedimentation. And then we have this unique UHT metamorphism at around 1 billion years in domain 2. How was it caused? It is not present in the East Antarctic bloc. It is present in the Indian bloc. How did it happen? So we postulate, it is a postulation only, that this is because of the slab breakoff, and which caused asthenospheric upwelling. Now, there can be other reasons for this UHT metamorphism. People have said other models, but the question is, nobody denies that this UHT metamorphism occurred at around 1 billion years ago. This was followed by emplacement of Charnockite magma around 0.96 billion years ago. and a second granulite fascist metamorphism, which between the Indian bloc and the East Antarctic bloc, they were coming close together as they were moving towards together. So the coalition started. We have an granulite fascist metamorphism and tectonothermal reworking at around 0.98 to 0.96. And finally, at around 0.9, the entire thing became one block with another phase of tectonothermal reworking. And here we believe this became part of the Rodinia at this stage around 0.9 billion years. It is not at 1 billion years as was previously thought, but India became part of Rodinia at around 0.9 billion years ago, not at 1 billion years. And this was first pointed out by Lee and others in their paleomagnetic measurements that at 1 billion years, India and Antarctica were not close, but they became close only at 0.9 billion years. And that is precisely what we got from here as well. The Chilka Lake domain evolution is based on the work of Bose et al. 2016. The summary of this particular thing is that they consider that the Chilka Lake domain, the Eastern Ghats Belt domain 3, was not a part of the Indian bloc before 0.5 billion years. So this is a hypothesis which needs to be tested, but the question is, it's a very interesting proposition that the people sitting here in Bhubaneswar today were not Indian before 0.52 billion years. So you became Indian only at 0.52 billion years during the Pan-African orogeny, according to this particular model. So this is a very interesting proposition. And I actually see quite a lot of difference in the metamorphic evolutionary history from the domain 3 in the domain 3 as compared to the domain 2. So whatever may be the interpretation, there is a definite discontinuity between domain 2 and domain 3. That is no doubt. So we look at finally the history of the continents that I take it slightly modified from Rogers, and we will look at Colombia, we'll look at Rodinia, and we'll look at Gondwana, particularly East Gondwana, because India was all along part of the East Gondwana, not the West Gondwana. So this is the map of Zhao et al., Gochun Zhao et al. In 2004, where they proposed that really there was a similarity in the Colombian configuration. There was a chance that India and Antarctica was together. So, but they were not sure, so they put a question mark between that. Now we know that the question mark no longer exists because the domain 1 of the Eastern Ghats Belt was in contact with the Napier complex at that time. And we did some work also, and we postulate that the domain 1 was actually a part of the Bungar Hills or the Wilkes land in East Antarctica, part of the Napier complex. So we have just limited that area, but in general, it was part of the Indo-Napier complex. So the Dharwar Craton lying on the west of the Eastern Ghats domain 1 became joined with the Antarctica as a part of Colombia at around 1.6 or 1.5 billion years. But the rest of the Eastern Ghats is nowhere to be seen at that point of time. And this I take from Shantanu Bhaumik's paper. That is where the different blocks, Indian blocks, what he postulates, the North Indian bloc, the South Indian bloc, and the Marwar bloc coming together at around 0.9 billion years ago. The Eastern Ghats, as a part of the Eastern Ghats Raynar orogenic belt, became amalgamated with the southern Indian bloc at around 0.9 billion years. That is what we also think to be true, but there are certain controversies, as you are well aware, that a group also believes that this joining took place, part of this joining took place at 0.5 billion years ago. So there are two views here. Of course, I personally subscribe to one and another person can subscribe to other, but only time will tell which one is correct. So this is the Rodinia model after Lee in 2008 at 0.9 billion years, where the Greater India and East Antarctica is joined by the Eastern Ghats Rhinar orogenic belt. So if you look at the paper of Lee, you will see that at around 1,000 million years ago, India was located near the poles. So that is what we observe. Also, that at 1 billion years, there is no similarity between the domain 2 and the Rhinar complex, but at 0.9, there is a strong similarity. So it is indeed, I believe it is indeed true that the 0.9 billion years is the time when Rodinia amalgamation took place and India and Antarctica became one. During the Gondwana formation, this is from Gray et al. 2007, the Eastern Ghats Belt was located here at the contact between the Indian Shield and the East Antarctic Shield, and there were the Pan-African orogens. So we have three major Pan-African orogens, the East African orogen, then the Kunga orogen, and the Brazilian Damara orogen. So the Brazilian Damara orogen was quite far off. The East African orogen was also quite far off, affecting Madagascar. But the Kunga orogen actually affected the East Antarctic Shield and the Indian Shield around 500 million years. So that is what we say, that they were together, but they were affected by the Kunga orogen, the far field stress effect of the Kunga orogen. So this is what we visualize in our model, that the Eastern Ghats Belt was part of the Indian geological map at around 0.5 million years, but we do get lot of reworking of at around this area. Lot of reworking at 0.5 billion years. Tapas Biswal first pointed it out in his 2007 paper, and then followed by many others, Shaival, Jayantananda, many others have shown. Now, the question is whether this 0.5 is the age of the amalgamation or this is an age of reworking. Now, I believe that it is an age of reworking. Others believe that it is the age of amalgamation. So this is a general talk. So I will, this is not only my research, so I will project both the views here, and maybe someday we will conclude about which one is the correct view. In my opinion, it is this model, that is the far field stress effect of the Kunga orogen, which caused the terrain boundary shear zone to form in the Eastern Ghats. And we got a lot of dates of 0.5 billion years in both zircon and monazite here in this. Previous people also got a lot of dates. We also got a lot of dates, but we also got 0.9 GA dates here, which is in this paper published this year. So we believe that this is a zone of reworking and due to the far field stress effect of the Kunga orogen. But as I said, there is another model which says that this is actually the time when the Eastern Ghats Belt got connected with the rest of India in the Bastar Craton. So only time will say which one is correct. So the major outcome, I just summarize the different parts of the Eastern Ghats Belt bear evidence of connected to supercontinents of Colombia, Rhodesia, and Gondwana. And the Eastern Ghats Belt preserves the story of three assembly and dispersal of supercontinents for more than 1 billion years. And the current architecture of the Eastern Ghats Belt was largely produced during the formation of Rhodesia, but for two models. One is on the Chilka Lake domain, whether this was part of India during the Rhodesia. That is one question. And the other model, that is whether India joined with the Bastar Craton. So both on the eastern side and western side, there are controversies regarding Pan-African amalgamation. But I personally believe that the amalgamation took place during the Rhodesia time, and the Pan-African time, it is only the reworking that we observed. So this is what I had to say in this talk, and it is most honored to share this platform. I hope I have not taken more time. I said 40-45 minutes, and I think it is almost that time I took. And I am thankful to the organizers for this invite. Now I can see old friends here, so it's nice to meet you virtually. And this is an organization that I note that they are organizing a lot of academic talks, and so I hope that they will do that even more in future. And so I wish this organization a very productive and successful future. I don't think that retired geoscientists of the Geological Survey of India, they have such organizations everywhere, but the Odisha chapter is quite active. And thank you very much.